Okay guys, today we are going to talk about electron affinity and electron gain enthalpy. Did you think that electron affinity and the electron gain enthalpy has the same idea? No, the electron gain enthalpy and the electron affinity is a two different things. These two have two different ideas. But lot of people think that electron affinity and electron gain enthalpy are the same thing. These two have the same idea. So even in your resource book, they clearly mention that electron affinity and the electron gain enthalpy are two different things. Before I explain about these differences between these two, I would like to explain about that what is the electron gain enthalpy and how it is work. So in the simplest way, we can explain that electron gain enthalpy, and we can define that electron gain enthalpy when we added the electron to a gaseous state atom. When we added the electron to a gaseous state atom, there will be energy difference. Okay, as example, in here there is a atom called M. When we added electron to this atom, it will form M minus anion. So in here, in that reaction, there will be an energy difference. In that energy difference, we call as what? Electron gain enthalpy or electron gain energy. So that electron gain enthalpy can be a positive value or negative value. It can have a positive value or negative value. We know if enthalpy has a positive value, it is an endothermic reaction. Now, if it is a enthalpy has a negative value, it is an exothermic reaction. So there will be two reactions. What? Endothermic and exothermic. When the reaction is an exothermic reaction, delta H value should be what? It should be negative. When the reaction is endothermic, delta H value should be positive. So the electron gain enthalpy can be an endothermic reaction or exothermic reaction. How we explain that electron gain enthalpy is exothermic or endothermic? We can explain that using the electron configurations of the atom. We know there are two electron configurations. Mainly, one is stable electron configuration and other is half stable electron configuration. We can get an example for that stable electron configuration. There are NS2 electron configuration. That NS2 electron configuration is a stable electron configuration. NS2 NP6 is also stable electron configuration because these orbitals are completely filled with electrons. But in that half stable electron configuration, there are NS2 NP3 electron configuration. In that NP3, the p orbital is not completely filled with electron; it is half filled. So we can't put it into a category that is stable electron configuration. It is because it is half filled, so we call that configuration half stable electron configuration. Let's get the example for that stable electron configuration. We can get this example for that stable electron configuration. Second group of element have that NS2 stable electron configuration. As example, beryllium. What is the electron configuration of the beryllium? 1s2 and 2s2. So that s orbital is completely filled with electrons. When that electron gain that beryllium, when the beryllium gain an electron, it converts into a unstable electron configuration. Let's look how it is work. If we add to an electron to beryllium, new electron configuration is 1s2, 2s2 and 2b1. So this is an unstable electron configuration since there is only one electron in the p orbital. Since there is only one electron in the p orbital, so normally Atom does not like to go through a stable electron configuration to a unstable electron configuration. Atoms does not like to go from a stable state to unstable state. So we have to supply some energy. We have to give some energy to do that reaction. So it is an endothermic reaction, because in endothermic reaction energy will absorb. So we have to give some energy to occur to take place that reaction. So this is an endothermic reaction. Endothermic reaction. Since it is endothermic reaction, delta H value should be positive. Delta H value should be positive. So in here, that electron gain enthalpy of the beryllium should have a positive value, since it is an endothermic reaction. So we can say the second group of elements have positive value for electron gain enthalpy. Positive value for the electron gain enthalpy. So another example for stable electron configuration is NS2NP6. So each group element has the NS2NP6 electron configuration. We can get example for it, like neon. Neon have electrons, 10 electron, 1s2, 2s2 and 2p6. So this is a complete stable electron configuration. P orbital is completely filled with 6 electrons. So when we adding electron to neon, it will goes to a unstable electron configuration. So we have to add another electron. Since this P orbital is completely filled, that electron will go to the 3s orbital. So the new electron configuration of the helium, 1s2, 2s2, 2p6 and 3s1. So this is a stable electron configuration. Stable state. This is completely unstable state compared to its initial state. Unstable state. So like I mentioned before, so in here neon has a stable electron configuration. When we add in electron, it converts to the unstable electron configuration like this. So as I mentioned before, normally the atoms does not like to move from his stable electron configuration to unstable electron configuration. Therefore, we have to give some energy to do the reaction. So if we give some energy, it means it is an endothermic reaction. So that electron gain enthalpy of the neon should be an endothermic reaction. So we can say that elements of the group 18 also have the positive sign value of electron gain enthalpy. So elements of the group 2 also has positive values of electron gain enthalpy. Elements of the group 18 also has the positive values of electron gain enthalpy. Now let's consider about the elements of the group 5. Elements of the group 5. When we consider about elements of the group 5, the elements of group 5 has electron configuration like this: NS2, NP3. We get example for that. Nitrogen. Nitrogen electron configuration is 1s2, 2s2 and 2p3. Okay. This is a half stable electron configuration. It's not fully stable, but it is also half stable. In here, p orbital has only 3 electrons. When we add in electron, it converts into an unstable electron configuration. 1s2, 2s2, 2p4. So we can see now there is 4 electrons in the p orbital is stable compared to the that electron configuration of the nitrogen. So since it moves from a stable to unstable electron configuration, that should be also a endothermic reaction. That should be endothermic reaction, that electron gain enthalpy, because it moves from a stable electron configuration to unstable electron configuration. So that have also enthalpy value, that also have a positive enthalpy value, since this is a endothermic reaction. This is an endothermic reaction. Endothermic reaction. This is an endothermic reaction. Okay. Elements of group 2, 5 and 8 have positive value of electron gain enthalpies. These three have positive value of electron gain enthalpy. So compared to the other groups, this electron gain enthalpy of group 3, 5 and 8 are a little bit higher compared to the other groups. So we can see now group 2, 5 and 8 elements have positive signs of enthalpy values. When compared to other groups, they have negative sign of enthalpy values, but group 2, 5 and 8 have positive sign of enthalpy values. So now let's see how the enthalpy values of other groups change. Let's consider about the elements of the group 1. We can get example for elements of group 1 as lithium. Lithium has electron configuration 1s2, 2s1. So this electron configuration is not a stable configuration, since the s orbital completely doesn't fill. So when we adding electron to that lithium, it will give an electron configuration like this 1s2, 2s2. This is a stable electron configuration compared to this. We know that 2s2 is a stable electron configuration. This is an unstable electron configuration. So in here, the group 1 elements, when we add an electron to a group 1 element, it goes from a unstable state to a stable state. So it would like to move from his unstable state to a stable state. So we don't need to give some energy to do that reaction. It will release energy from itself to do that reaction, since he like to move his unstable state to a stable state. So this is an exothermic reaction. Exothermic reaction. Delta X theta value should be negative. In the case of chlorine, chlorine is a seven group element. When we add an electron to chlorine, it will create chloride anion. That enthalpy value also negative value. It nearly close to the 349 kilojoules per mole. So you see in here, electron configuration of the chlorine. 1s2, 2s2, 2p6 and 3s2, 3p5. In here, with electron configuration, considering last two orbitals, 3s2, 3p6. You see, this is a stable electron configuration. But this is an unstable electron configuration. So normally, as I mentioned before, atom is like to move from its unstable state to stable state. So that electron gain enthalpy of the chlorine should be negative value, since it is an exothermic reaction. So this is the exothermic reaction. This is the exothermic reaction. Exothermic reaction. We can justify that negative sign of the delta H value using this electron configuration of chlorine previous state to after gaining electron. So this is how it works. When the atom moves from this stable state to unstable state, it will be a endothermic reaction when the electron gain. When we add the electron to atom, it moves from this unstable state to a stable state. It will be a exothermic reaction since the energy released from the reaction. So now let's focus about how that electron gain enthalpy varies through the period from left to right. So generally, through a period left to the right, the delta H theta negative value will be increased and the positive value will be decreased. For reason for that is when we go through a period left to the right, the atomic radius will be decreased. So when the atomic radius decrease, the distance between the nuclear and the outer energy state also decrease. So when we compare these two atoms, this atom has a very small atomic radius and this atom has large atomic radius compared to this atom. So when we adding the electron to the outer energy state, when we adding electron to the outer energy state of both these atoms, which nuclear give the more attraction to that electron? Yes, that atom give a more attraction towards that electron, because this there is a small distance between that electron and the nucleus. But in here, the distance between that electron, it means that electron comes to the outer energy state. So distance between the outer energy state and the nucleus will be large compared to this distance. So smaller distance means that nuclear can attract highly compared to the other atom. So that electron gain enthalpy will be decreases when the atomic radius decreases. When we talk about down to a group means that atomic radius will be increased. So the distance between the nuclear and the outer energy state will be also increases. So that means that attraction force of nuclear to the electron will be also weak. So we have to give more energy to attract that electron to the energy state. So that's why when we go down to a group, that electron enthalpy, the positive value of the electron enthalpy will be increased and negative value of the electron enthalpy decreases. So that's the way that electron gain enthalpy varies from through the period and the down to a group. So at the end of the video, I will show you the some real values of electron gain enthalpy of some atoms. Now I talk about the electron gain enthalpy. So in the very beginning of the video, I told you that electron gain enthalpy and the electron affinity are two different things. Lot of people don't think these two are the same thing. No, this has two different ideas. Even in your research book, they mention that electron affinity and electron gain enthalpy has two different ideas. So in here, let's focus about what is the difference between these two things. So this is the connection between electron gain enthalpy and electron affinity. Electron gain enthalpy equal to the negative sign of the electron affinity. It means if the electron gain enthalpy, your electron gain enthalpy is a positive sign. Let's get we have some electron gain enthalpy value that has around positive 439 kilojoules per mole. The electron affinity of that atom will be what? Yes, positive, not positive, but negative 400, negative 400, it will be negative 439 kilojoules per mole. So, electron gain enthalpy or electron gain energy and the electron affinity have same value. If atom has the electron gain enthalpy, the electron affinity of that atom also will be the same value. But the difference that the sign of that value will be opposite. If that is a positive sign, electron gain enthalpy, then electron affinity will be negative sign. If the electron gain enthalpy is negative, then electron affinity will be positive. So that is the connection between these two. So we can't say that electron gain enthalpy always equal to the electron affinity. It is not equal to the electron affinity. It is equal to the negative sign of the electron affinity. So negative sign of electron affinity means if the electron gain enthalpy has a positive sign, the opposite sign will be taken by electron affinity of this atom. If the electron gain enthalpy of atom is a positive, sorry negative, then the electron affinity of that atom will take positive sign. So always the value is same. If the always the value is same when compare the electron gain enthalpy and the electron affinity of that atom, but the difference is that it will take the opposite sign. So let's focus on how it will be changed. How that electron affinity is opposite sign of that electron gain enthalpy. If the electron gain enthalpy has a positive value, then electron affinity of that atom will be as a negative value. If the electron gain enthalpy has a negative sign, then electron affinity of that atom will be positive sign. So this is the connection between these two things. So now let's clarify how it is that when the electron gain enthalpy comes with positive sign, how electron affinity comes with negative sign. So what is the meaning of that affinity? We can call that affinity mean what is it? The similar verbs to affinity is love. It means atom's affinity to take electron from the outside. So if atom like to take electrons rather than releasing the electron, so it means its affinity is high. Affinity has a high value. It means affinity has a positive value. As an example, we know that fluorine electron gain enthalpy nearly around minus 349 kilojoules per mole. Okay, this is fluorine gain enthalpy. It is a minus value. Then electron affinity of that atom will be, yes, electron affinity of that fluorine atom will be positive 349 kilojoules per mole. 349 kilojoules per mole. So that is the thing. It means we know the electron is a highly electronegative atom. It is really like to gain the electron from the outside. So when compared to other atoms of that period, the electron, fluorine atom has a very small atomic radius, since it is really like to attract electrons. So it means its electron affinity is high. Electron affinity is high. If the electron affinity is high, if an atom like to gain an electron, that means it has a positive sign. It has a positive sign. But in electron gain enthalpy, we talk about that it is released energy. We know it is if an atom release energy, then mean it is, but it has a negative sign. So that's the difference between these two. That's what you have to understand. It is not a big thing, but a lot of students take it wrongly. They also think electron gain enthalpy equal electron affinity. No, it's not equal. The electron gain enthalpy equal to the opposite side of the electron affinity. Okay, I think now you understand the difference between the electron gain enthalpy and the electron affinity, and now you know how the electron gain enthalpy varies through the period and the down to a group. I think these things you understand after watching this video.